algebra, we primarily deal with solution of linear equations. In such cases, the variables such as x1, x2, etc. are discrete numbers. In calculus, primary object of our interest is continuous functions. However, in numerical analysis, all we can deal with are discrete numbers. So, in numerical calculus, first we have to understand that how we can combine this idea of discreteness in numerical analysis with the idea of continuous functions as we use in calculus. Once we resolve this issue through what we call interpolation, we will then go toward numerical estimation of differentiation and integration, and we will use this idea finally to the solution of ordinary and partial differential equations. You will see that our goal will be to convert this ordinary as well as partial differential equations into systems such as Ax equal to b systems, which means simultaneous linear equations, and we already know how to solve such equations, and eventually solution of those equations will give us the solution of ordinary and partial differential equations. We will start with chapter 18 of your textbook, that is the interpolation, and here we will resolve the issue of discrete versus continuous. Then we will go to chapters 21-23 where we will talk about numerical differentiation and integration. And finally we will get into the ordinary and partial differential equations. That would be chapter 25, 27, 29, 30 of your textbook. You will see that this ordinary and partial differential equations, through a process which we will discuss later, this process is called discretization, we create this Ax equal to b systems which are large sparse linear equations. So you will find that this matrix A will be very large, much larger than the homework problem that you have solved, and they will contain mostly zeros. Since many of the physical problems we deal in engineering can be modeled as ordinary as well as partial differential equations, we will also talk some aspects of modeling of physical systems. We will take some examples of physical systems, we will model them, we will solve them, and we will plot the results in this section of your course. You can start reading from the chapter 18 of your textbook, that is the interpolation chapter. And also, this would be a good time to grab an engineering mathematics text and take a look at the chapters of ordinary differential equations, both the initial as well as boundary value problems. Similarly, all engineering mathematics texts will have some chapters of partial differential equations. So get into these partial differential equation chapters and take a look at the parabolic as well as elliptic partial differential equations. That's all for now. Thank you, and I'll see you in next class with the topic interpolation.